The Constitution of India, Preamble. We, the people of India, having solemnly resolved to constitute India into a sovereign, socialist, secular, democratic republic and to secure to all its citizens justice, social, economic and political, liberty of thought, expression, belief, faith and worship, equality of status and of opportunity, and to promote among them all fraternity, assuring the dignity of the individual and the unity and integrity of the nation. In our Constituent Assembly, this 26th day of November 1949, do hereby adopt, enact and give to ourselves this Constitution.
Hello my dear children, welcome back to the physics class. Hope you all are doing well. Let's recall what we have learned in the last class. In the last class, we discussed about the working of an AC generator, the stages at which the EMF becomes maximum and minimum. Let me give a brief explanation about that. Now, look at the figure. Here, the rotation of armature at different stages is given. Look at the first position. That is, the armature is perpendicular to the magnetic field lines. Okay, in the first stage, the armature is perpendicular to the magnetic field lines. So, what happens at that position? There is no change in the magnetic flux. So, what happens? Whether EMF will be produced there? No, EMF is not produced, EMF will be 0 since there is no change in the magnetic flux. Now, see to the second figure, that is the armature has rotated and now the armature is parallel to the magnetic field lines. Okay, in the second figure, the armature is parallel to the magnetic field lines. At that time, what happens? There is a change in the magnetic flux linked with the coil. Okay, there is a change in the magnetic flux. So, what happens when there is a change in the magnetic flux? EMF is induced. Okay, and at that position, the EMF is maximum. Now, look at the third stage. Here, the armature is perpendicular to the magnetic field lines. So, there is no change in the magnetic field or there is no change in the magnetic flux. So, EMF produced will be 0. Okay, and the next stage is the armature is parallel to the magnetic field lines. So, what happens? There is a change in the magnetic flux and the EMF produced will be maximum. And at the last stage, what happens? The armature is perpendicular to the magnetic field lines. So, there is no change in the magnetic flux and the EMF produced will be 0. And now you can see the graphical representation of the AC. Now, look at the figure. What happens? Here the EMF is changing, isn't it? EMF increases and decreases and there is a change in both the direction. EMF changes in both the directions. Rendu directionilum EMF change ആവുന്നുണ്ട്. Okay, അതായത് 0 ന്ന് തുടങ്ങി maximum ആയി വീണ്ടും decrease ആയി and it goes in the opposite direction. What happens? So, a complete cycle is over. So, all these things we have discussed in the last class. So, let me ask you a question. In an AC generator, whether you are getting alternating current or direct current. In an AC generator, we are getting alternating current. Okay. And do you know the frequency of AC generated in our country for distribution? It is 50 Hertz. That is, the armature is rotating how many times? 50 times. Now, tell me what is frequency? Frequency is the number of cycles in 1 second. Frequency is the number of cycles in 1 second. Now tell me, what is speed? It is the time taken by the armature for a full rotation, and it is represented by the letter T. അതായത് നമ്മൾ കഴിഞ്ഞ ക്ലാസ്സിൽ കണ്ടിരുന്നു അല്ലേ, ആർമേച്ചർ റൊട്ടേറ്റ് ചെയ്തുകൊണ്ടേയിരിക്കുകയാണ്. അപ്പോൾ എ ബി എന്നുള്ള ഭാഗമായിരുന്നു നോർത്ത് പോളിൻ്റെ അവിടെ, സി ഡി അപ്പുറത്തുമായിരുന്നു. അപ്പോൾ എ ബി ഒന്നിങ്ങനെ കറങ്ങി തിരിച്ച് നോർത്ത് പോളിൻ്റെ അവിടെ എത്തുമ്പോഴാണ് വൺ കംപ്ലീറ്റ് റൊട്ടേഷൻ. ഇസ് ഇറ്റ് ക്ലിയർ? സോ ടുഡേ we are going to discuss about DC generator. The working and the parts of a DC generator are almost similar. Let's see to the parts of a DC generator. Look at the figure. You can see field magnet and an armature coil is there, two brushes, and R1 and R2 are the split rings. Okay, that is the difference between an AC generator and a DC generator. In an AC generator, we are using slip rings, whereas in a DC generator, we are using split rings, half rings. Okay, so now we will study the working of a DC generator. Now, let's see the working of a DC generator. Okay, just see the figure. Here, AB is near to the North Pole and CD is near to the South Pole. Okay, suppose the armature is moving in the clockwise direction. Okay, so what happens? AB moves up and CD goes down, isn't it? So, according to Fleming's right hand rule, what happens? You are holding your forefinger in the direction of magnetic field. Thumb represents the direction of motion. So, what happens? The middle finger represents the direction of induced current. So, you have to hold the finger like this. Here, the current is flowing from A to D. So, in this case, the current is flowing from A to D. And in the outer circuit, what happens? Current flows from B2 to B1. Is it clear? അതായത് ഇവിടെ ഈ ആർമേച്ചർ ക്ലോക്ക് വൈസ് ഡയറക്ഷനിൽ കറങ്ങുന്ന സമയത്ത് അവിടെ എന്തുണ്ടാവും? മാഗ്നറ്റിക് ഫ്ലക്സ് ലൈൻസിൽ ചേഞ്ച് ഉണ്ടാവും, EMF ഇൻഡ്യൂസ്ഡ് ആവും അല്ലേ? ആസ് എ റിസൾട്ട് വാട്ട് ഹാപ്പൻസ്? കറണ്ട് ഇസ് ഇൻഡ്യൂസ്ഡ് ഇൻ ദ കോയിൽ. ഈ കറണ്ട് ഈ ആർമേച്ചറിൽ ഡെവലപ്പ് ചെയ്യുന്നത് എന്ത് സംഭവിക്കും? ഔട്ടർ സർക്യൂട്ടിലോട്ട് വരുന്നത് ഏതിൽ കൂടിയിട്ടാണ്? ഈ ബ്രഷസിൽ കൂടിയിട്ടാണ് അല്ലേ? സോ ഹിയർ ദ കറണ്ട് ഫ്ലോസ് ഫ്രം B2 to B1. Is it clear? Now just see the other figure. അതായത് ഒരു വശം ഇങ്ങനെ കറങ്ങിയിട്ടുള്ള ഫിഗർ. Now CD is near to the North Pole and AB is near to the South Pole. Is it clear? Again, what happens here? In this case, the current flows from D to A. Okay, because it is moving in the clockwise direction, CD മുകളിലോട്ട് പോവാണ്. Again, you have to hold your finger right like this. That is according to Fleming's right hand rule, the current is moving from D to A. അതായത് ഇതിനുള്ളിലോട്ടാണ് അല്ലേ? അതായത് D ന്ന് അങ്ങനെയാണ് പോകുന്നത്. Here, in the second case, the current is flowing from D to A. Look at the brushes. Here, the brushes are not moving. അതായത് ഈ രണ്ട് ബ്രഷസ് ഇവിടെ കോൺസ്റ്റന്റ് ആയിട്ട് നിൽക്കുകയാണ്. ഈ സ്പ്ലിറ്റ് റിംഗ് ആണ് ഇങ്ങനെ കറങ്ങിക്കൊണ്ടേയിരിക്കുന്നത്. മനസ്സിലാവുന്നുണ്ടോ? Again, what happens here? Current is flowing from B2 to B1. മാറുന്നുണ്ടോ ഇവിടെ? ഔട്ടർ സർക്യൂട്ടിൽ കറണ്ട് ഡയറക്ഷൻ മാറുന്നുണ്ടോ? ഇല്ല. Here current direction of current is not changing. So that is the speciality between AC generator and DC generator. Okay, so what is the difference? In an AC, the direction of current is changing. അതായത് galvanometer നോക്കി കഴിഞ്ഞ് കഴിഞ്ഞാൽ it will be deflecting to both the sides in the case of an AC generator. Whereas in the case of a DC generator, what happens? The direction of current is not changing. So we can see the galvanometer needle will be deflecting to only one side. So which arrangement helps to produce current in one direction? Can you tell me which is the device that helps in producing the current in one direction? Yes, split ring commutator. Okay, അതായത് ആർമേച്ചറിൽ ഉണ്ടാവുന്നത് AC തന്നെയാണ്. ഇവിടെയും ആർമേച്ചറിൽ ഉണ്ടാവുന്നത് AC തന്നെയാണ്. പക്ഷേ ഔട്ടർ സർക്യൂട്ടിലോട്ട് വരുമ്പോൾ what happens? This changes into DC. So here split rings helps in this arrangement. Is it clear? So in the DC generator, which type of current is produced? In DC generator, DC current is produced. The working is similar to that of AC generator itself. AC generator പോലെ തന്നെയാണ്, പക്ഷേ ഇവിടെ എപ്പോഴും ഔട്ടർ സർക്യൂട്ടിൽ ഒരേ ഡയറക്ഷനിലാണ് കറണ്ട് ഫ്ലോ ചെയ്യുന്നത്. കാരണം ഈ രണ്ട് ബ്രഷസിൻ്റെ ഇടയിലും ഈ സ്പ്ലിറ്റ് റിംഗ് ഇങ്ങനെ കറങ്ങിക്കൊണ്ടേയിരിക്കുകയാണ്. ഓക്കെ, now look at this graphical representation. The EMF produced in an AC generator, DC generator and a battery is shown. Analyze the graph and find out the peculiarities. Now, look at the first graph. It is the graph of an AC. Okay, what is the speciality of AC? AC changes its direction continuously. Okay, so here the direction of current is changing. Positive half and negative half and. So here the direction is changing. What about the magnitude or EMF? Here the EMF increases and decreases. Okay, so in the first figure direction changes, and second point EMF increases and decreases. Now look at the second case. It shows the EMF obtained from a battery. Is the direction of current changing here? No, the direction is constant. It's a straight line, isn't it? So the direction is constant. What about the EMF? The EMF is also constant. Okay, it is not increasing or decreasing, it is constant. Now look at the third case. It is the EMF obtained from a DC generator. Okay, so which type of current is obtained in a DC generator? It is direct current. What about its direction? Is the direction of current changing here? No, the direction of current is not changing. What about the EMF? The EMF increases and decreases. The EMF increases and decreases. So this graphical representation is very important. So go through it.
How do you tackle power cuts? What's the common alternative source of electricity? Yes, it's the generator. Let's see how an electric generator works. Electric generator works on the principle of electromagnetic induction and converts mechanical energy into electrical energy. An electrical generator consists of following parts: a permanent magnet, a rotating coil, conducting brushes, 2 rings, and an axle. The coil ABCD, usually made of copper, is placed between the 2 poles of the permanent magnet. It is rotated inside the magnetic field mechanically by rotating the axle externally. This induces a current in the coil. The 2 ends of the coil are connected to 2 separate rings attached to an axle. The inner sides of the rings are insulated from each other and the axle. Two conducting stationary brushes B1 and B2 touch the external conducting edges of the two rings. These brushes are generally made of carbon or copper. The axle is rotated to move the coil in such a way that arm AB moves up and arm CD moves down. By applying Fleming's right-hand rule, the induced current is generated in these arms along the direction DCBA. The current in the external circuit moves from B1 to B2. After half a rotation, arm CD starts moving up and the arm AB moves down, which changes the direction of induced current. Now the current in the external circuit flows from B2 to B1. Such a current which changes direction in a circuit after equal intervals of time is called an alternating current, abbreviated as AC, and the device is called an AC generator. In order to get a unidirectional flow of current, a device called the commutator is used. Instead of two separate rings, a commutator keeps the current flowing in one direction instead of back and forth. In this case, the stationary brushes form contact with opposite parts of the commutator. As the coil turns, it cuts across the magnetic field and current is induced. At the first half turn of the coil, the contacts between commutator and the brushes get reversed. Each brush now touches the opposite segment that it had been touching during the first half turn. By doing so, the brushes keep the current moving in one direction only. Such a device, which generates a direct current that flows in only one direction, is called a DC generator.
Now, tell me what all things we have learned today. We discussed the working of a DC generator, and what are the parts of a DC generator? Magnet, armature, split rings and brushes. Okay, the only change is that in AC generator we are using slip rings, whereas in DC generator we are using split rings. So what happens? The split rings rotate in between the brushes along with the armature, and as a result of that, what happens? Always in the outer circuit, the direction of current is always same, and in the outer circuit the current always flows in the same direction. So, in a DC generator, we are getting direct current. Compare the two generators and study well. If you have any doubts, you can contact me. Hope you all understood the two types of generator. See you all in the next class with a new topic. That's all for today. Bye.